going to work through some half-life calculations, and just before we get started, I want to remind you of the two methods we could use to solve for half-life, to solve for cycles, to solve for the initial or the final amounts. So the first method is using the formula, where you use 1 over 2 to the nth power times x initial equals x final, where n is the number of half-life cycles, x sub 0 represents your initial amount of your sample, and x sub f represents the final amount of the radioactive substance. Now, n, as I said here, is your number of cycles that you go through. So the way you would have to calculate n, if you're not told directly, is you would need to take the total time that has passed by and divide it by the half-life. Now remember, the half-life is the amount of time that it takes for 1/2 of a radioactive isotope to decay. So if you were to start with, say, 100 grams of a radioactive isotope, after 1 half-life cycle, you would have 50 grams remaining. After the second half-life cycle, you would have 25. After the third, you would have 12.5. So that goes on, so on and so forth, for how many cycles. You just keep dividing the amount in half. Now, some students prefer the chart method. So if you're going to use the chart method, you want to make a chart where one heading is your amount of your sample, and you could either call the second heading cycles, which is your n, or you could say time. I always use cycles. Now, what you have to remember with this method is that your very first cycle is 0, because that represents before any cycles have occurred. And you would start with your initial amount here, and you would think it through. Now, the problems I'm going to be using are from the final facts review sheet that we have been working on over the last several days. And we're going to go to the back where we have half-life calculations. Now, with this first problem, the formula method is going to work best. So it says, how many years will 50 micrograms of lead-210 decrease to 5 micrograms? And they're telling you the half-life of this lead-210 is 25 years. I'm going to label some things here. So x initial is 50 micrograms. That's how much you started with. It's decreasing to 5 micrograms. So that's going to be your x sub f, 5.0 micrograms. And they also tell you that the half-life is 25 years. So T1 half is 25 years. So we're going to have to solve for the cycles first, and then we will use this formula to help us get to the half-life and the total time passed. So the formula is 1 over 2 to the nth power times x initial equals x final. So we're going to solve for n. So 1 over 2 to the nth power. X initial is 50 micrograms. X final is 5 micrograms. Now we have to isolate our variables, so we're going to have to divide both sides by 50. And I don't have a lot of room here, so I'm just going to tell you what I'm doing. I'm dividing both sides by 50. If I divide both sides by 50, that's going to leave on this side 1 over 2 to the nth power is equal to 0.10. Again, I divided both sides by 50. Now, I need to get the n in the numerator. So to do that, I'm going to have to cross multiply. So that's going to leave me with 1 equals 0.10 times 2 to the nth power, and I'm going to divide by 0.10. That's going to cancel it here. And 1 divided by 0.10 on this side is going to give me 10 equals 2 to the nth power. So 10 equals 2 to the nth power. Now this is not a perfect square, so you're going to have to use the property of logs, or you may know it better as left, right, center. Now, what you do is you take the log of both sides. So if I take the log of this side, that gives me with log of 10 here. If I take the log of this side, That's going to allow me to bring the n down as a coefficient. So it's going to give me n times the log of 2. And I wrote that in pencil. I know that's not really showing up dark, but that says log of 10 equals n times the log of 2. Now, to isolate my n, I'm going to divide both sides by log of 2. That's going to cancel it here. So you're going to plug into your calculator log of 10 divided by log of 2. And that's going to give you n equals 3.32. And I'm not going to worry so much about sig figs here, but this is like more than 3 cycles, but less than 4 cycles. I'm going to leave that in my calculator. Okay. Now, this is the cycles. The question wanted us to figure out how many years. How many years is what we're calling total time. So I want to know how much total time has passed. So now that we know our n, we can plug into this formula. We know the n and we know the half-life. So to find total time, we're going to cross multiply n, the cycles, times the half-life. I'm going to write that formula. I'm going to put TT for total time is equal to n times the T1 half. And all I've done there is rearrange the formula from the other sheet. So n is 3.32. Now, I've not cleared my calculator. I'm just writing this down for space saving here. Times the half-life, this was given as 25 years. So you're going to take that and multiply by 25 years. And now we're going to just round this to the nearest day. So your total time that has passed is going to round to 37 days have passed. This one was a little more complicated, but you would have to use the formula method to get this to a specific amount of time. Otherwise, you would only be able to guesstimate. All right, so that's problem number 1. Let's look at number 2. Number 2 says the half-life of thorium-234 is 18.72 days. I'm going to write down my givens over here to keep them all together. 18.72 days. Now, we'll say how many days are needed. So again, we're looking for total time for 3/4 of a given sample to decay. Now, notice they've only told us that 3/4 of a given sample has decayed. So we're going to have to define our x initial and our x final in terms of fractions. So you're assuming if 3/4 have decayed, that means you started with the whole sample. So we're going to just let that equal 1. We'll say 1 gram, but it will be the whole. Now, if 3/4 of it has decayed, how much of it remains at this moment? So 1 whole minus 3/4 leaves you with, that's right, 1/4. I'm going to keep this in terms of fraction, 1/4 of a gram. Let's call it that. All right, so 1/2 to the nth power times your initial, 1, equals your final, 1/4. Or you can put 0.25 if you'd like. So this, if you multiply 1 times 1/2 to the n, you get 1/2 to the n, kind of simple, equals 1/4. Now we need to get our variable in the numerator. So we're going to cross multiply. So 2 to the n times 1 gives you 2 to the n, and 4 times 1 gives you 4. Now this is a perfect square, so you don't have to go back and do the left, right, center, because you can tell this is a perfect square. We know that 2 squared is 4, so that means n is 2. This means 2 cycles have occurred. All right, so we know the half-life and we know the cycles again. So we can go back to the formula here. Since we know the cycles and the half-life, cross multiply, and we can get the total time passed. So to get your total time, I'm going to say 2 times the half-life, which was given here as 18.72 days. And when you multiply that out, you're going to get 37 days. Oh, I apologize. I just realized something as I'm looking over here at my key up here. If you go back to number 1, some of you are probably screaming at me, that's not right. If you multiply 3.32 by 25, you should have on number 1 got 83 years. I'm so sorry. I've got my problems worked out over here to save time because my videos only let me video for 10 minutes. So I was trying to get through them more efficiently. I should have looked a little more carefully. So everything is correct though in number 1 up until